Hello, my name is Zhaohua Chen from Environment and Climate Change Canada. I'm presenting on monitoring Arctic sea ice deformation using ALAS2 Sentinel-1, RedaSat-2, and ISAT-2 satellite sensors. Studying sea ice deformation can help understand ice motion and polar climate. Understanding the response of source signals to sea ice thickness and deformation changes is a critical step for sea ice monitoring. We are investigating how InSAR observations correlate to surface deformation and ice draft growth. The methods include three steps. First, variations of SAR intensity were compared with SAR surface height measured from ISAT-2. Second, coherence variations over ice from interferograms generated with different acquisition intervals at different months were assessed. Third, the response of InSAR measurements to the ice draft measured from an ice profiler was studied using time series analysis paths. Our study area is in Cambridge Bay, Nunavut, Canada, and this is the scene coverage from Sentinel-1 and ALAS-2 and RedaSat-2. And we have 5 locations to compare the InSAR observations, and also ice profiler located here and our reference point. We used data of FQ13 from RedaSat-2, ALAS-2, and Sentinel-1 IW mode, and images acquired over the winter period from 2018 to 2019. And here I show you the comparison of the Sentinel-1 intensity versus the surface height from the ISAT-2. And the correlations at these two dates are along three tracks of 2 days here, ranging from 0.5 to 0.8. And here how the interferograms from the RedaSat-2 look like. And this is the interferograms generated from Sentinel-1 during January to April. You can see the fringes becoming wider and wider. And this is ALAS2 interferograms. You can see the interferograms are very good even from after 2 months with ALAS2. And here the InSAR results from ALAS2, Sentinel-1, and this is RedaSat-2 at different locations. In ALAS-2, 2 locations always going up, and another 2 locations going down, and 1 location nearly not changed. However, in Sentinel-1, all of them are going down. This is ice draft, telling the thickness changes always rising from October to end of June. And RedaSat-2, only differential results available. Conclusion: it was found that InSAR interferograms formed over sea ice during January-April may represent vertical deformation responded to the steady ice growth. Results indicated that uplift and subsidence patterns varied in different locations, and the magnitude of deformation was a response to thickness changes. The trend of InSAR observations from Sentinel-1 were also consistent with the ice surface height changes detected from ISAT-2 along 2 of the ground tracks. L-band ALAS-2 achieved higher coherence over longer acquisition intervals compared to C-band RedaSat-2 and Sentinel-1. C-band with 12-day acquisition interval was more suitable for deformation analysis than 24-day acquisition due to temporal decorrelation. Sub-backscatter was found to be sensitive to the surface height changes along the ground track of ISAT-2. And thank you.